Hi everyone. Now we would be learning about replication. So in this video, we would be focusing on single leader architecture. In the next video, we'll be learning about multi-leader. And in next video, we'll be learning about leaderless architecture. Okay. And along the way, we would also try to learn all these topics which I have mentioned over here. All right. So let's get started. So the first question is, why do we need this replication? So let's try to understand this three reasons one by one. So assume that this is the users table which is only present in this database server. Okay. And due to some reason, this server got destroyed, or maybe the disk in this server got corrupted. So it means that you have lost the access to this data, right? Your data is lost. So in order to prevent this stuff, what we can do is we can copy this data across multiple database servers. Okay. The entire data over here is copied to multiple database servers, so that even if this database server got destroyed, we can still access this data, right? So this was the first reason. The second reason is to ensure the availability. So assume that you have only one database server where this users table is present, and due to some reason this database server got down, it got crashed. So all the users who are trying to read the users table will not be allowed to do that, right? They will get the error response because this database server is down. But now, since we have replicated this data across multiple database servers, if anyone wants to perform a read request or write request, and if this database server is down, then no need to worry. Their request can go to this database server, right? Or this database server, correct? So here we are ensuring the availability. Even if one server is down, one database server is down, our read or write requests are not stopped. Okay. The second or the third reason is low latency. So what we can do is we can put this database server in USA, this database server in India, this database server in Russia. So all the Americans would be reading the data or writing the data to this database server. So they would be facing low latency. Similarly, Indians would perform the CRUD operation on this database. They would also face low latency, right? So these are the main reasons because of which we replicate the data across multiple database servers. All right. Now let's learn about single leader architecture. So in single leader architecture, we would be having one leader and multiple followers. All right. There can be n number of followers. The job of this leader is to handle the write request. Write request means insert operation, delete operation, update operation. Whereas followers' responsibility is to handle the read request, like select operation. Okay. So this is all about single leader architecture, which you need to know. Now let's try to learn different modes of replication. Okay. The first one is strictly synchronous replication. So the thing is, as we discussed, this leader will be processing the write request. So assume that this is the users table, right? Which has ID, name, and status column. And now I am firing this query, update query, where I am basically updating my status from available to busy. Okay. So this is a write request. So obviously it will go to the leader. Now this leader will basically execute this query. Okay. Point to note over here is it will just execute that query in RAM. It will not commit that thing. It will not write the commit message in the write-ahead log file. It is just executing that query. So after executing the query, the leader will simultaneously ask all the followers to execute the same query, okay, and give the acknowledgement. So this follower will also execute this query. This follower will also execute this query. All of them will try to execute that query. And once they are successful in doing that, they will give the acknowledgement. And point to note, they will also not write the commit message in their log file, write-ahead log file. Okay. So all the followers will also execute this query and give the acknowledgement. Once the leader sees that all the followers has executed and given me the acknowledgement, Then the leader will commit that changes and return the success response to the client. Also, one more thing. If any followers fails to send the acknowledgement to the leader, in that case, the write request will be failed. Okay. That's why in strictly synchronous replication, one disadvantage is the writes are slow. That's the first disadvantage, because leader will be waiting for all the followers. And second is the writes are not highly available. Writes are not highly available. Okay. Because if even one follower goes down, the write request cannot be processed. Okay. And strictly synchronous replication ensures that your system is strongly consistent. Strongly consistent means your entire system, this thing, acts as a one single unit. Meaning, if you perform a read operation, you would be seeing the latest data. Okay, you would be getting the latest data, right? Because the leader is first sending the first replicating the changes to the follower, then only it marks that as successful, right? The second mode of replication is asynchronous replication. In this replication, the write request will first go to the leader. The leader will directly process that write request and commit the changes. Okay, and once it commits the changes, it will return the success response to the client, right? And after that only it will try to replicate. Okay, so obviously there would be some lag. It can be 1 second, 10 seconds, 1 minute, whatever. So after that replication lag, the followers would be having the data. That's why this system is said to be eventual consistent, meaning that followers are lagging behind the leader, but eventually they would be catching up with the updates. Okay. And this system has this risk of data loss, because see, once this leader gets the write request, it will process that request up and commit the changes. All right. But the thing is, let's say at this point of time, the leader goes down, right? It has not replicated the changes to any follower. Before that, only the leader goes down. So the data which was, you can say, updated in leader is lost, right? But the advantage of this system or this replication is the writes are fastest, because the leader is not waiting for the acknowledgement from the followers. Okay. And second advantage is the writes are highly available, right? Even if this follower is down, the leader can process the write request. Earlier, we were not able to do that in the strictly synchronous replication. So I hope now you understood the second mode of replication, which is asynchronous replication. Now the third one is quorum synchronous replication. All right. So over here, quorum means minimum number of nodes that must agree for an operation to be considered successful. So by the way, this is almost similar to the strictly synchronous replication. Only difference is this word. In strictly synchronous replication, this leader was waiting for all the followers to give the acknowledgement, right? But in quorum synchronous replication, we would wait for quorum number of followers to give the acknowledgement. Okay. And generally, the value of quorum in most of the system is taken as n upon 2 plus 1. So if you have 3 followers, then the right quorum is taken as n upon 2, which is 3 upon 2, which is 1 plus 1, 2. So this leader will be waiting for 2 of the followers. It can be any 2. Okay. Once this leader gets the acknowledgement from any 2 followers, it will return the success response to the client, right? So this is, you can say, optimization over strictly synchronous replication. The advantage of this system is the writes are faster compared to the strictly synchronous replication, and they are comparatively highly available. Okay. Now the question is, how does the replication takes place? So there are two types of replication: logical replication and physical replication, right? You are basically supposed to send this update or whatever query you are performing to the followers, right? So that can be done in two ways, either physically or logically. If you are doing logically, then you have three options: statement based, row based, trigger based. In statement based, you will directly stream this SQL statement. Okay, whatever statement you are going to perform on the leader, that same statement will be streamed to the follower, and follower will perform the same statement, right? Second is row based. In the row based, you will be writing what exactly has been changed on a specific row. So this is how you would be streaming the update from leader to follower. Okay. So generally, row-based replication is used over statement-based replication. The reason is this statement-based replication has many non-deterministic functions. For example, one of the function is now. Okay. So this function basically gives you the timestamp. If you execute this function on leader, it will give you some timestamp. And if you replicate this statement and then execute this on follower, it will give you different timestamp, obviously, right? So because of that, your data will be, you can say, diverge. So that's a problem. Okay. That's a drawback of statement-based replication. And because of that, we use row-based replication. If ever you use logical replication, then this is the best option, row-based replication. But this row-based replication also has its own disadvantage. The disadvantage is, if we have updated, let's say 20 rows, right? Then this SQL statement will only occupy one line in the log file, right? But this particular row-based replication will occupy 20 lines if you have updated 20 rows, right? So that's the drawback. But again, this drawback is small compared to this one. So that's why we generally use row-based replication. Okay. Similarly, the second type of replication is physical replication. In physical replication, we have this write-add log based replication. So in one of the previous video, I've already explained you this write-add logs. Okay. And I've also explained you that most of the databases stores physical information like the page number, the offset number, and the binary data, right? So in this write-add log based replication, we directly take this stuff and replicate that to the follower. And that's why this replication is fastest among all the replication. But the drawback of this replication is your leader and the followers should be using the same version of the database. If leader is using Postgres 18.4, then the follower should also use the same version, right? Because you are dealing with the physical level stuff. That's why. Okay. So I hope now you understood how the replication takes place. So in the very beginning of this video, we saw that why replication is useful. But once you introduce replication into your system, you would be facing lots of challenges. And these are the major challenges which you would face. Okay. Out of this, we would be covering only the third and the fourth one. For the first and the second one, I would be creating a dedicated video because I don't want this video to be very long. So the first one is monotonic read consistency violation. All right. So we'll understand this diagram later. But before that, let's see the demo. So this is my Twitter account. And currently I have 32 verified followers. Okay. Now, if I refresh this particular dashboard, I am still seeing 32 premium followers. Let's again refresh this. This time I am seeing 31 premium followers, right? Again, let's refresh this. This time I am seeing 32 premium followers. Okay. So let's go back to this diagram and try to understand this particular violation. So first of all, let's try to understand what is monotonic read consistency. Then we'll understand violation. So what monotonic read consistency says is, once you see a new value, you should never see an older value compared to the current value. All right. Assume that I have 34 verified followers on Twitter, and this follower is having the latest value, which is 34, right? But my read request went to this follower, which has 32. Okay. Initially, I was shown 32, right? But when I refreshed the dashboard, my read request went to this follower, which was showing 31 verified followers. Okay. So this is basically violating this monotonic read consistency. Monotonic read consistency says that once you see a new value, okay, I was seeing this particular value, my read request should not go to a follower which is having comparatively older value. So this follower is having the older value compared to this. This is having 32 and this is having 31. So my read request should not go over here. This is what monotonic read consistency says, right? My read request can go to this follower. It's completely all right, but it should not go to this follower. Okay. Right. And if my read request goes to this follower, it should not go to this follower, because then 32 will be older compared to 34, right? So Twitter is basically violating the monotonic read consistency problem. You can correct me if I am wrong. All right. And by the way, it completely depends upon application. For social media application, it's completely okay as far as showing the number of followers which a specific user has. But in some other application, this might be disaster. For example, banking application. In banking application, let's say I'm shown $500 for the first read request. Then I'm shown $100. Obviously, it's not good, right? So it completely depends upon application. Okay. And by the way, I'm assuming that I'm using asynchronous replication in my system. Okay. This is asynchronously replicated, right? If it is synchronously replicated, then obviously all of the followers would be having the latest value, 34. If I have 34 premium followers, right? Now let's say I want to solve this violation. How to do that? In order to do that, I have two ways. The first one is I use sticky session. That is, my read request will always go to a specific follower. For example, this follower. So I will always see only one value. I will never see the fluctuating value, right? So this is how we can prevent this violation. And the another question is, what if this follower goes down? Right? If I will only read from this follower, then what if this follower goes down? In that case, we would fall back to the leader. That is, my read request will go to this leader. All right. So I hope now you got this violation and how to overcome this violation. The second kind of violation is read your write consistency violation. So over here, let's say you are on any social media application, for example, LinkedIn. You create a post. Okay. So this is a write request. Hence, it will go to the leader, right? This leader will send a OK response, meaning your post was created. Okay. And assume that we are using asynchronous replication. It means that after some duration, after a replication lag, the update from the leader will be replicated to the follower. All right. Till then, this follower will show the stale value. Okay. So now, if you perform a read request, if you try to fetch the post, the follower will say that there is no such post because the follower is still having the stale value. The leader has not yet replicated the changes, right? So you might feel that your write is lost. Okay. Your post creation is lost. In comment section of YouTube, I've seen that some person comments same thing multiple times. So what probably could have happened is that person created the comment, he pressed enter, but when he refreshed the screen, he was getting the comments, but in that comments he was not seeing his own comment, right? That's why he probably comments again. This is just my guess, but I hope you are getting what is read your write consistency is and how it is getting violated. Read your write consistency means whatever you are writing, you should read that. But here you are not reading that. I mean, you are trying to read that, but you are not getting the value. So this is the violation. So in order to solve this violation, we basically pin the user. That is, if you perform any write request, obviously that will go to the leader. But for the next few seconds, all your read requests should also go to the leader so that you see the up-to-date value, up-to-date data, right? And generally, all your read requests will go to this leader for the same time duration which it takes to replicate the changes. Okay, so this is how you can prevent the violation of read your write consistency. But over here, you introduce one more problem. The problem is this leader is handling lots of stuff. It is handling writes as well as reads. So in order to eliminate this problem, we use something called as fragmented pinning. So over here, the thing is, if you are creating the post, then the read request for the post should be directed to the leader. All the other read requests, like reading the profile, that should go to the follower. Why? Because post is updated. You have not updated your profile. Okay, so profile can be served from this follower, right? So this is what fragmented pinning is.